This presentation is delivered by the Stanford Center for Professional Development.
It's time to delve into a continuation of our last great topic. Okay? So it's time to continue a bit with our friend, the interactor. And if we think about the interactor, an action listener, so last time we talked about like having buttons and buttons generated action events, remember that? So we're going to do a brief review of that and push it a little bit further. So one of the things we talked about is how in your program, say in your init method, init, somewhere you might have public, void, init, and inside here you would set up sort of the parts of your program that you want to actually do something, like the various interactors, so that when someone clicks on them something happens, and then you would say add action listeners, and what this would do, listeners, is basically say, hey, I got some buttons in my program. I want you to be listening for buttons. So when someone clicks on a button, I want you to call a particular method for me called action performed. And then based on when you call action performed, I'll figure out what button was clicked and then actually do something. Okay? So over here we had our friend public void action performed. And action performed would get as its parameter something called an action event. And an action event, we just refer to it as E, was basically what it would check to see what action was actually taken, or basically which button was actually clicked. Okay? So hopefully you remember that. That's just a little bit of a review from last time. Now, when we got this action event, we said there were a couple things you could do with it. There was actually one main thing we talked about what you could do with it, and you could figure out which command was actually the thing that caused this action event to be generated by saying, hey, you know what I want to do? I want to pull out as a string, and I'll just call it CMD for command, the command or the name of the interactor that caused this action performed method to be called. So here I would say E dot command equals E dot get action command. And what get action command does, it's just a method of this action event that says, hey, I'll return to you the name of the interactor as a string, and buttons names are basically just whatever displays on the button. So then I can have some ifs in here based on this command. If command dot equals, and I can check for some name, then I might want to take some action based on that button. It turns out there's something else you can ask this action event E for other than the action command. You saw this very briefly last time in the program that we did, and you're going to see it a little bit more now, so I want to spend a little bit more time on it, which is something where you can say, hey, E, what I want to get from you is not the action command, I want to get the source of the action. Okay? Now, the interesting thing about what get source returns to you, actually, let me not put the semicolon here right now, is get source actually returns to you an object. Okay? It returns to you the object that caused this event to be generated, which means if a button was clicked, E.getAction command will get the name of the button. E.getSource will actually give you a reference to the button object. So what you're getting back from this is an object. You're getting a reference to that object. So what does that mean for you in sort of your everyday life? What that means is over here when you want to set up your initialization, you could say, hey, I want to create a button. And so I'll have some button I want to create. So I'll say new J button. And maybe that button I want it to say hi on it. Okay? And so one thing I could do is I could say hi equals new J button. And hi, what I'm going to do is make that an instance variable. So somewhere down here in my program where I have my ivars, my instance variables, I would have private J button hi. So I just do the declaration of a variable called hi, which is of type J button, and then in my initialization method, I actually create that button with the label hi on it, and then I go ahead and add it somewhere to one of the control bars in my program. So I would say add hi maybe to the south control bar, because we really like adding things to the south control bar. It's just fun when buttons show up on the bottom of our screen. So we say add it there, and then wait for something to happen. So add my action listener in case this button gets clicked. Now when the button gets clicked over here, what I can do is I could actually ask command to get its name, right? So I could ask the action event to get the action command name, and then I could say something like if command dot equals and the name of the particular button that I created over there happens to be hi. If it happens to be hi, then there's something I want to do, like maybe I want to print something on the screen or whatever the case may be. That's one way I could write this, and this is kind of the classic way that you've seen it written before. Okay, that's the way you saw it last time. The other way I can write it with my friend getSource is rather than getting the name of the command and checking to see if the command is equal to hi, I can actually say, hey, you know what? Maron told me about this thing called e.getSource. As a matter of fact, I don't even need this line for command anymore. Let me just comment it out so I don't erase it. Okay? And I can say if e.getSource, this returns an object to me. I want to check to see if that object that it returns is my hi button. So here I check directly, is it equal to hi? And then I do whatever I was going to do. So this has exactly the same effect as before. It's checking to see if I've gotten a button that is the hi button that was clicked. Okay? So the difference between these two things, if you kind of think about them, right? One of them is I'm just using a name as a string, and the other ones I'm using the actual object. Now, if I think about more deeply what that means, if I think about the name over here, right? If I think just in terms of the name, I never need to be able to refer to the actual object. Which means if I don't need to refer to the actual object again over here, I don't necessarily need it as an instance variable. I only need it as an instance variable if I'm going to refer to it again in some place that's in a different method than some other method I may have already used it in. So let me show you an example of what I mean by that in code to make that more concrete. Okay, so if we come over here to code, here's essentially the code I just wrote for basically creating a button. So it's just the code I wrote on the board, right? Except I just made the font bigger. I create a button with the name hi. I put it in the southern region. I add my action listeners to listen for that button getting clicked. When the button gets clicked, I say, hey, is the thing that got clicked this button that I created? Here I actually called it hi button instead of just hi. Over there I shortened it to hi so it would take up less board space. If it's actually the source of that action is my hi button, then I will print out hello there. Okay? So I can go ahead and run this program. And if I run this program, this is, I click hi, you get the same thing I saw before. Every time I click hi, I get hello there. Now, alternatively, I could have written this a slightly different way, which is the way you saw last time. Okay? What I can do here is I can say, hey, when I'm going to do the add, just go ahead and create that button and add it all in one line, because I don't need to have some variable that stores the button. Because down here, I don't need to check for the source of what that action event was. I'm going to say, hey, action event, give me your command. And the command is going to be the name of the button. So I no longer need a variable to actually store a reference to the actual button object, because this is going to give me the name whenever I need it. And so as a result, notice here I don't have an instance variable. So this is one of those things that's a trade-off that also should give you a little bit more insight into when you have instance variables versus when you don't have instance variables. You need to have the instance variable in the case where you need to, wrong one, and I want the new one. You want the instance variable in the case where you want to be able to refer to this variable in some method that's different than perhaps the method in which it got created, right? So I created the button over here and store it somewhere, but I need to be able to refer to it in some other method, so it's got to be an instance variable. If I don't need to refer to it in any other method, which is what I saw in the second case, okay, I don't need to refer to it again here. As a matter of fact, there's no other place I need to refer to it after I create it, then I don't need to store it anywhere. Okay? Any questions about that?
So if we don't use instance variables, what if we have two buttons and we both put it hi, and we say command.equals hi? How does the computer know?
So that's a bug in your logic, right? The computer shouldn't try to figure out which one, because if you give it two buttons with the same name, it says, I have no idea, right? And it's going to cause you problems, so don't do it. And if you want to see what happens, go ahead and try. But it's a bug in logic, not a bug in what the computer is executing. Okay? Any other questions?
What will getSource return if you didn't name it as your button as a variable?
It's still going to get the actual button. So you're saying in this other case over here, what is this thing going to return if I didn't create a variable over here?
Yeah.
This thing's still going to return some reference to your object. The only issue for you now, though, is you have no way of checking for equality with some object, right? Because if you don't have this as an instance variable, you can't check to see if that thing's equal to hi button. So if you created hi button over here and just immediately added it and never kept track of it over here, this guy would return to you a pointer to hi button, and you'd say, great, I got a pointer to hi button. How do you know it's hi button? You don't, because you have no way of comparing it to the actual hi button you created. Okay, that's why we need to store it. Alrighty. So why do I show you these two different ways of doing it? And the reason why I show you these two different ways of doing it is now you're actually going to make use of this with respect to some other interactors that you're actually going to see where we care about doing get source as opposed to get the action command. So what we're going to do next is we're going to say, you know, a lot of times in programs what you really want to have is you want to have some way of letting the user specify some text in a program that's running interactively that's not in the console, right? They'd like to be able to type something in. So let me just show you an example of this. So here's a little program that's got what we refer to as a text field down here. And I called it name. And so if I say, hey, my name is Maron, it says, hello, Maron. And then I say, oh, no, I was just joking. My name is really Sally. Most of you don't know this. It says, oh, hello, Sally, right? So it's just some way of being able to have some text field over here that the user fills in, and this is an interactor, right? This is just one field. It's not on the console. And then do some action, and the action we happen to do here is just to write something to the console that makes use of the text that the user actually typed in, okay? So how do we get something like that to work? So what we need to do is have an interactor that's called a text field, okay? And basically a text field is just that thing you saw, right? It's a little place where someone can type some text as an interactor, so it shows up on one of the control bars, and then potentially when they hit enter, you get some action event that tells you you need to actually, or if you want, you can do something with this text, okay? So that's the basic idea. What you really get is a box, and that's all you get with it. If you want to add a label to that box, like we added name over here, okay, we need to sort of specify that. And I'll show you how to do that in just a second. But what you really get is the box. And when the user types in something and then hits the enter key, then potentially some event is generated for you. Okay? So how is that actually set up? So the thing we want to create is called a JText field. Okay? It's just another one of these interactors, just like you saw before where we had checkboxes and combo boxes and all that stuff. It's just called a JText field. I'll name this one TF. To stand for text field. And what you do when you create a new one of these is you say new JText field. And what you give it as a parameter, here's the funky thing, you don't give it its label. The label doesn't come with the text field. You need to create the label separately. What you give it is the size of that text field, how big it should be in terms of the maximum number of characters that would show up in there. So if you say 10, for example, what you're saying is I want to have some text field that will hold at most 10 characters. And if you use some font that's variable width, it automatically gives you the size of like 10 M's, because M is the widest character, in case you didn't know. That's just life in the city. Okay? Now, the funky thing about this, right, relative to this action performed, is when the user hits enter, if I didn't do anything else, you would not actually get this call to action performed. Because action performed is only called for you for buttons. So what you need to do is after you actually create this text field, you need to say, hey, you know what? I need to let you know about this text field as something that can generate actions. And so the way you do this is it looks a little bit funky, but you tell the text field dot add action listener this. Okay? You don't need to worry about all the what does that actually mean at a very low level. All you need to know is you're telling this text field, hey, guess what? You're going to be able to generate actions now, and the thing that you're going to let people know when you generate some actions is yourself, which is why we passed this. Okay? But anytime you create a text field, and you don't just do this once for all text fields. If you have multiple text fields, you need to send this add action listener this message to each one independently. We only have one here, so we only need to do it once here. But what this basically does is says, oh, text field, yeah, you can now generate these action events as well. So after you create it and you sort of set up this line, and you would want to add it somewhere into your program, right? So somewhere in your program, you would probably say add TF, and we might add TF, for example, in the south, because we add everything in the south. Okay? When someone types something into TF and hits enter, then it will generate some call to action event for you, or for action performed, and pass you an action event. Now, once that gets set up, how do you actually figure out what was the text field that generated this event, right? Because you could have multiple text fields that someone could have typed into it, hit the enter key. what you're going to do is you're going to use your friend that you just saw, e.getSource. So inside here, what you're going to say is, if e.getSource is equal to TF. And at this point, all kinds of warning bells should go off for you. And so maybe inside here, you want to do something like you want to do a println, where you want to say hi, and then add to it the text that's in that text box. And the way you do that is you just say the name of whatever the text field is, and the message you send it is get text. And what it will give you back is it will just return to you, this thing by itself just returns a string of whatever is in that box when the user hit enter. Okay? So this will write out hi, and then whatever text they typed in, just like you saw in the program, except there it was writing hello, and maybe that's what we want to do. But the warning bells that should be going off now, what's the problem if I've just written the code like this? What? It's not an instance variable, right? So I have no way, if this is my init method over here, I have no way of being able to refer to TF again out here. So I need to create the instance variable, right? If this is my init method, and I got public void init in front of it, right? What I need to do is this TF somewhere else in my class, let's say over here, which is where I declare my ivars, right, which is just lower down in the class somewhere, I need to actually have private j text field TF. And then over here, rather than declaring it, I just create the new TF. So I need to set it up as an instance variable. Okay, just like you saw in the example with the button, same kind of thing that's going on here, except this is a text field. Okay. So let me show you an example of this code in action. So here's a little text field example. What I'm going to do is I'm going to extend a console program, so I'm still going to have a console. In my init, I'm going to have something called name field. What's name field? It's just a private JText field, right? It's an instance variable, so I can save off name field. Name field I initialized over here to be some new JText field of size 10, right? It's exactly the code you just saw over there. Now what I also want to do, here's the one extra funkiness in the program, I want to give that box a label. So before I add this box to my control bar, I'm going to add a new JLabel with just says name. So all JLabel does is it just says, hey, I'm going to create something that's just this name, or just this particular piece of text. The text happens to be name, and I'm going to add that to my southern control bar. So first it's just going to write name out there, and then after I write name, I'm going to add my name field, which is going to create the box after name. And then I'm going to show you, I'm going to do exactly what I told you, where you have to tell, hey, name field, you're going to add action listeners of yourself, so that if you do anything, you're going to let someone else know that you actually have done some action when the user types into you and hits enter. And that means action performed is going to get called for you, because now you're going to be able to generate events to an action listener. And in action performed, we check e.getSource. We can compare against name field because we have that saved off down here as an instance variable. And we'll just write out hello and then the text associated with name field. Okay? And let me increase the text size here, just so it's a little bit bigger and we can all see what's actually going on. Set font. Oh, we'll do my old favorite, Courier24. Like, no, make it bigger. Yeah, the est set, just in case you speak German. So here, once again, Maron. Hello, Maron. See, and when it knows it's getting the event when I hit enter. All right, enter, 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 enter. See, that text just stays there. Enter, enter, enter. Yeah, it's another one of those things. It's only so much fun. Sally, throw in some Sallys. We're scrolling. Not a whole lot of excitement going on here. All right, this is good for about 2 minutes, maybe 1. All right, so we can do it. We can go ahead and do it this way, and now you can get information from a text box. Okay, any questions about the text box? In the back?
Does it just center everything along the bottom of the control bar?
Yeah, so basically the way the layout works is every time you add things, they just get added sequentially from left to right in whichever region you're adding them to, in this case the southern region, and the whole set of stuff gets centered. So if you want to space stuff out, what you actually need to do or add, for example, more JLabels that might have just spaces in them, and then it'll create more spaces between stuff. And there's no way I can hit you. I'll just leave it here, and you can pick it up after class. All right? So there's one other thing we can do that's kind of funky, is we can actually name the text field. Okay? So you might say, but Maron, this whole getSource thing, yeah, keeping around the instance variable, I'm not so keen on that. What I am kind of more keen on is giving things names so I can just refer to them by their name. And it's like, okay, that's cool. You can have a name. So here's that exact same example, just slightly differently. What I'm going to do is I'm going to add just one more line here. So this is exactly the same code I had before, except after I create the name field, I say, hey, name field, I'm going to give you an action name or an action command, and your action command is going to be name. So whenever you generate these events, yeah, I can check to see if your source is actually, or if the source of that event is you, or if I've given you a name, I can do the same thing I just did with buttons, which is down here, I can get action command. That gives me the string, which is the name of the object that created this event, and I can see if it's equal to name, which is the name that I gave it. Okay? So this just shows you a little back and forth. With buttons, I kind of showed you, yeah, a priori with buttons, you just name them because you always name buttons and you check against names. But you could actually check against the source of the button if you want to. JText fields is kind of backwards. JText field, you always, in some sense, have the text field that you can get with getSource. But if you want to refer to it by a name, you have to explicitly give it a name because name doesn't show up as part of it, right? If we want the label, we still need to add the separate label name over here. This is just naming the particular events that come from that box. That's all it does. Okay, so any questions about that?
When you specify the JText field and the amount of characters you take in, is that the maximum amount you take in or the maximum amount you show?
That's the maximum amount of shows. Yeah.
In this example, name field is still an IVAR. Is that necessary?
Yeah, name field is still an IVAR here. It's really actually no longer necessary because I don't need to refer to it over here. So if I wanted to, I could just do this. Little cut and paste. Thanks, IVARs. Thanks for playing. That's real nice of you. Yeah, and everything's, oh, no, I can't. That's why I added in here, because I still need to refer to it over here to get its text. Yeah, well, I could, to be honest, actually what I could do is I could just call getSource here and get its source and then get its text. So I really don't need to, but it's just better style because it makes it cleaner that I'm getting the text here. So there is a way around it, but the cleaner way is to actually do it this way. Alrighty, let me get rid of the declaration here. That's life in the city. So any questions about that JText field? Oh, yeah. You can. And I'll show you that in, about 20 minutes. But, yeah, and 3 seats away. So before we get there, it's time for something completely different. And that thing that's completely different is to say, kind of gets to the question in the back of the room, which is, hey, Maron, these things are all sort of showing up centered on the bottom of the screen. Could I actually have these interactors laid out a different way than this way that they're getting laid out for me? And in fact, you can, and strangely enough, the thing you use to do that is called a layout. Okay? So a layout controls the layout of the particular interactors. Now, it turns out when you used your friend the console program or your friend the graphics program, what you got was a layout that was called the border layout. And as a matter of fact, you already saw the border layout. You saw the border layout last time. It looked like this. Okay? Which is you had some center region, you had a north, south, east, and west borders, which is why this thing's called a border layout. Okay? And what happened with this border layout, if PowerPoint wants to comply, okay, is that the center was where all the action takes place. The console program would add a console to the center automatically, right? That's just what happens in a console program. And a graphics program would add a gcanvas to the center automatically, which is where you're going to draw all your stuff. And the other regions are only visible if you add stuff to them. So in the very early days when you had a graphics program that was all just graphics, you would say, hey, Maron, nothing showed up is the south region. Yeah, because we didn't put any interactors there. So these interactor regions only show up if we actually put interactors on them, right? And we said these are referred to as control bars. So you saw these last time. So how do I consider different kinds of layouts? So there's a couple other layouts to also think about. There's something called a grid layout. Okay? And the way a grid layout works is you actually create an object called a grid layout, and you specify in that grid layout how many rows and columns are in the grid layout. So we might say 2 rows and 3 columns, which means we're going to have a layout that looks something like this. It's just a grid with 2 rows and 3 columns. Okay? And I'll show you the code for this in just a second so we can get into the nitty-gritty details. But conceptually, here's what it is. Now, when I add items, so what I do is I say, hey, you know what? I want to set my layout to be this grid layout. What now happens when I add items is it will add items, the items being the interactors, one by one, starting at the topmost row in the leftmost center, in the leftmost square, and every time I add a new element, it moves over by one until it gets to the end of the row, and then it automatically comes down. So it goes sequentially across row by row. But it allows me to kind of lay things out in a grid if I want to actually be able to do things in a grid. So let me show you an example of what a grid layout might look like. We're all done with you, little guy. So grid layout. Here's a simple program that does a grid layout. What we do is we start off in our init method by saying, hey, you know what? I want to create a layout. So I want to set the existing layout that the program is going to use to be a new grid layout that's 2, 3, 2 rows by 3 columns. Now, one thing that's interesting about this program, if you look at grid layout example, it does not extend console program. It does not extend graphics program. These are not its beautiful house and its beautiful wife and its beautiful children. What have I done? What I've done is said I'm just going to extend a program. I don't want you to create a console for me, and I don't want you to create a gcanvas for me, because I want to take up the whole screen with my buttons, baby. So that's what I'm going to do. I'm going to add 6 new buttons, and these buttons are just going to get sequentially added in the order you just saw, and then I'm going to say, hey, add my action listeners, and I'm not going to do anything. I'm just going to ignore the buttons. But what the reason why I'm doing this is I just want to see some big fat buttons. Yeah. Oh, yeah. Look at that. 6 buttons that take up the whole screen. It's a grid. My interactors fill up the grid. The layout takes up as much space as possible in the screen, and more importantly, each of the interactors that I put into a grid cell takes up as much space in the cell as possible. So this button comes along and says, oh yeah, I got so much space, I'm laying out. And you're like, why? Why does it do this? This is the most brain damage thing ever. I don't need like a 2-inch by 3-inch button. And the reason why is, how did you find that so quickly? Talking heads, we won't talk about it right now. Maybe afterwards. It's just frightening. It's like having a sound effects guy. Check this out. As I resize the window, all buttons, small and cute, big buttons. That's why we have layout managers, because the layout manager just conceptually says, this is how your layout's going to be. And it says, I'm going to handle all the dynamics of resizing and all that stuff for you, because people resize the window, but I need to know how things are laid out. And if you give me more space than I need, I'm just going to take it up. Okay. Grid layout, not so useful. Okay. Just something to see, so you can, if you see it in the book, you know what it's talking about. There's another kind of layout, which is called a table layout. There's actually another kind of layout called the flow layout. We're not going to talk about it all. Okay? But there's something called a table layout. And a table layout is basically just like a grid layout, except for the nicety. So you also give it a number of rows and columns. Except what it says is, rather than having each one of the interactors fill up its cell to the maximum possible size, I'm just going to give that interactor as much space as it needs in that cell and no more. Okay? So what does that mean? That means if I come in here and rather than a grid layout, I say I want to create a new table layout, and I run this. Oh, I need to add more imports. All right. All right, little guy. Let me just grab the imports from over here. Program.star. Be happy. Oh, graphics. Sorry. It's already there. Come on, table layout. Oh, table layout. Let me just show you the nicer example of table layout. Sometimes in life, you just got to get ugly with it. We got ugly with it. Oh, table layout, there's table layout. Okay? 6 buttons still. We can still resize the window, but the buttons are just given as much size as they would actually need. They don't fill up the whole region that they actually want. Okay? So table layout's actually something slightly more useful for us than grid layout. So then this question came up before, which was, hey, can I actually link like buttons and text fields together? to create something a little bit more funky. And in fact, I can do that, and I'm going to show you that in a context of something a little bit more interesting, which is a program that allows for conversion and temperature. So this one's actually in the book, so I didn't give you the code because all the code is actually, the code is all in the book, so I didn't give it to you on a separate handout. Basic idea is we write out a label called degrees Fahrenheit, a label called degrees Celsius, and inside here we can type in some value, and if we click Fahrenheit to Celsius, it will automatically, fill in the Celsius field with the corresponding value. So 32 is 0 Celsius. The other thing that's kind of funky is I don't necessarily have to click the button. I can type in, say, some value and hit enter, and that's just like clicking the button. Ooh, interesting. So how do I create this program? Well, if you think about this program, first thing I'm going to need is these things are not supersized, but they're all laid out in a grid. So I'm going to need a table layout that has 2 rows and 3 columns. The first element that I have here is just a label. Then I'm going to have a field that's a text field. As a matter of fact, I'm going to have a specialized kind of text field, and there's 2 specialized kinds of text fields, something called an int field and a double field. They work just like text fields, except you're guaranteed to get an integer value or a double value from them. And you might say, but Marilyn, what happens if someone types in A and wants to convert A to a temperature? Oh, I clicked the wrong button. They want to convert A to a temperature. It says enter an integer, and it brings up this pop-up box and gets in their face, and then you say, oh yeah, sorry, my bad. So it guarantees you get an integer, okay? And then I'm going to have a button, and somehow I want to link the button and the text fields to do the same action. So let me show you the code for that. It's actually a lot shorter than it looks like. First thing I'm going to do is say, hey, set the layout to be a table layout. Notice once again here I'm extending a program because I don't want a console or a canvas created for me. I want to be able to specify the whole layout. So I'm just extending a program. I say set the layout to be a table layout 2, 3. And again, we're going to go sequentially through all the elements. So what I want to have in the first element, basically the first thing I'm going to add to my layout, I don't specify until down here. The very first thing I'm going to add to my layout is degrees Fahrenheit as a label. Then I'm going to add some Fahrenheit field. Well, how did I create that Fahrenheit field? I actually created it up here. What I did first was declaring it as an instance variable. So Fahrenheit field is an int field, not a JText field, but an int field, which is just a specialization of a JText field to just give you back integers. Other than that, it works just like a text field, except here I just wanted to show you int field, so it's an int field. So I create a new int field. I specify its initial value, not its initial size, but its initial value. Its initial value is 32. Okay? Then what I say is, hey, Fahrenheit field, I'm going to set your action command so that when you generate actions, the name associated with the actions that you generate is going to be f dash greater than, which we can just think of as arrow C. That's going to be your name. So I set its name, and then I say you're going to generate action events, so I'm going to add an action listener to you of yourself. Okay, just like you saw before with the text field, except now we're doing with an int field. We do exactly that same thing with something called a Celsius field. Celsius field is also declared to be an int field. It starts off with an initial value of 0. We set its action command to be C goes to F as opposed to F goes to C. So we give it a slightly different name, and we also set it to listen to action events, okay, or to generate action events. And then we're going to lay out our grid. So first element of the grid is the label, as we talked about before. Next element of our grid is our little text box that's going to actually have the numeric value in it. And last element of our grid on the first row of the grid is a button that's name is F goes to C. And you look at this and you say, hey, Maron, if I have a button that's name is F goes to C, and I named this guy F goes to C, aren't I getting back to the previous point over here of, wasn't this the logical problem where I actually have 2 elements that have the same name? Yeah, I have 2 elements that have the same name, but I want to do exactly the same thing in both cases, so it doesn't make a difference. Okay? So what I want to do is say if someone clicks the button, I'm going to do the conversion. So I'm going to have some code that's going to do the conversion. If someone types something into the text field and hits enter, I'm going to do the same thing. So this is something you see a lot of times on the web where, for example, if there's a search engine you use, you can type in the search engine, then click search, or you can just hit enter. How many people actually click the search button? No one. How many people just hit enter? Yeah, isn't it nice that you can just hit enter? Yeah, that's the same thing we're doing in this program, which is why we went through this extra rigmarole of setting this action command here, because sometimes it's just nice to hit enter. Okay? And we do exactly the same thing for degrees Celsius. The name so we add the label degrees Celsius, we add the Celsius field, and then we create a new button whose name is the same as the action command for the Celsius field. And then we add action listener. So that sets up our entire user interface, our entire graphical user interface, or the GUI. And then when the user clicks on a button, we say, hey, let me get the action command. If the action command is F goes to C, which means either they type something into the Fahrenheit field and hit enter, or they click the button, then I'll get the value in the Fahrenheit field. Because Fahrenheit field is an integer field, it just always gives me back an integer. And I do a little bit of math. If you don't know the math conversion from Fahrenheit to Celsius, don't worry about it. This is just how you convert from Fahrenheit to Celsius. You take 9/5 times the Fahrenheit value minus 32, and that gives you the Celsius value. Now you know. And what I do, more interestingly, is I set the value in the Celsius field to be whatever value I computed. So someone just typed something into the Fahrenheit field and hit enter or click the F to C button, but what I do to update the screen is I change whatever value is in the Celsius field. And I do sort of the reciprocal of that, or I should say the complement, reciprocal, the inverse, the mirror image. How many words can you come up for the same thing? Of that, if someone does C to F, which is I get the value that's in the Celsius field, I do the math that's necessary to convert from Celsius to Fahrenheit, and I set the Fahrenheit field. And that's the whole program, right? Here's my instance variables. So if I run my little temperature program, I have my label, I have my initial value, and I have my Fahrenheit to Celsius. And if I put in some value here, like 100 degrees Fahrenheit is 38 degrees Celsius. And 212 degrees Fahrenheit will not touch the mouse, just hitting the enter key. Enter does the same thing as if I click the mouse. And same thing on this side. I can say 0 Celsius. Yeah, 32. Good times. And now I've created a whole program with a graphical user interface, and now I can like resize, and it just does, you know, oh, it always centers for me. Isn't that nice? And if I make it too small, well, these things don't get too small. It just says, hey, you know, I can't see the screen. That's life in the city. Okay? Any questions about that? Oh, can you use the mics, please? I got to keep reminding everyone to use the microphones.
Can you adjust the width of the grid, like each cell within the grid?
There are ways that with table layout you can actually give it what are referred to as hints to actually specify different sizes for things. And I just didn't do that here. It's in the book if you want to do it, but we're not going to sort of push it that far in this class to use it. But there are ways you can. Yep. So one final thing that we want to do is you might say, oh, this is all good and well, Maron. Yeah, and that's kind of fun. But really what I like is some text and some graphics together. And I want some interactors. So I kind of want it all, right? I want text, I want graphics, I want interactors. You think back to the days of yore, you think Hangman. Hangman, you had text and you had graphics, but you didn't have interactors. Here you have interactors, and I showed you an example with interactors and text where you click the button and it said hi and, you know, gave your name or whatever. Now it's time to roll the enchilada and put them all together in our friend text and graphics. Okay? So what text and graphics is going to do is basically what we want to think about is having some console in the program and a graphics canvas in the program and interactors in the program so we can just go to town and do whatever we want to do. How do we make this happen? Okay? First thing we're going to do, let me write a little bit of text on the board just to get up, get a little blood circulating in your legs. Anyone know that thing about blood clots in your legs where you're actually traveling too long on planes and blood clot? Yeah, we won't talk about that. I just give you a small hint. It may save your life. If you're ever traveling on a trip that's longer than 2 hours, sometime during the trip or multiple times, get up and walk around. It will save your life. But, and if you're ever giving a lecture for longer than 2 hours, get up and walk around because it'll save your life too. Not because of blood clots, but because your students will kill you after 2 hours of you just sitting there going like, oh, and now the grid bag layout, which we're not going to get into, but is an actual kind of layout. So text and graphics. Two great tastes that taste great together. You can decide which one's chocolate and which one's peanut butter, but it's text and graphics. And so it's like Hangman, but with interactors. So what we're going to do is we're going to extend a console program. And the reason why we're going to extend the console program is we still need our friend the console. That's where we're going to get the text portion of doing this interaction, is from having a console program. And so when we have a console program, what this gives us is it gives us the borders that we've come to know and love. Right? It gives us the north border and the south border and west and east. And these are places where we can still place our interactors. The interesting thing is what's going on in the center region. And what I told you before is a console program fills up the center region with a place where you can put text. And that's all you can do with it. So what we're going to say is, hey, console program, what I want to do is in the center region, I want to give you a different layout and put stuff in that layout so I can potentially have some text and some graphics. So what am I going to do? The first thing I'm going to do is I'm going to think about having some layout Okay? And my layout's going to apply to this middle region. The important thing to keep in mind is the console program, what it used to do was create a console that filled up the entire region. Now what I'm going to get is a console as my first element, which means however I do the layout, whatever I do in that layout, the very first thing, like let's say I have a grid that has 3 elements to it in one row, the first element of that will be my console. That you don't have any control over. Just because of the way the console program works, the first elements of whatever layout you use when you extend the console program and create a layout for it will always be whatever your text is. Okay? Now, you said, hey, Maron, you were also going to tell me about graphics, but if I'm doing this in a console program, how do I get graphics? We do the little trick we did in Hangman, which is there's this thing called a G-canvas. And what we're going to do is create a G-canvas, and a G-canvas, importantly, is actually something that we can add to a layout. So what I can do is say, hey, create my console program. I'm going to create some layout. Let's say I'm going to have a grid that's, I'm going to create some sort of layout, like maybe I'll have a grid layout that's 1, 3, which would give me this. My first thing is already taken up by my console. What I'm going to do is create a G-canvas and add that G-canvas as my second element. And just to be super cool, to give you something that normally you'd have to pay $12.95 for, but I'm going to give it to you for free, we're going to create another G-canvas and add it over here. So that's G-canvas dose. Okay? So what we get is console and 2 different G-canvases, plus we can still add interactors all around our screen. And at this point, you should be looking at this in shock, horror, and delight and going, okay, Maron, let's all put it together in 5 minutes, because it's just that easy. So here's how it looks. Text and graphics. I extend console program, okay, because that's where I'm going to get my console. In my init, I say set the layout. I want a new grid layout. Remember, grid layout, the elements of the grid layout expand to take however much space you give them. That's what I want in this case. Because what I want to say is I want to have a grid. I want to give the console 1/3 of the whole grid and 2 canvases, another thirds of those grids, and grow them to as large as they can be. Okay? Then what I'm going to do is I'm going to create 2 canvases. So I need to have some instance variables to refer to these canvases. I'm going to have 2 canvases, which are just type is G-canvas. They're private variables. I will call them the right canvas and the left canvas. Okay? And I'm also going to have a text field in this program just for laughs, just because I can. Okay? That's going to be one of my interactors, because I want to have interactors, text, and graphics. What am I going to do? First thing I'm going to do is I'm going to say left canvas, create a new canvas. Add that canvas, and when I do this add, it's adding it to my layout. Okay, I'm adding a whole canvas. So what does that do? It says, hey, you told me you got a grid layout here. I've already filled in the first thing with the console, because that's what I do. I'm a console program. You just told me to add a canvas. Element number 2 will be the canvas. I do the same thing again for right canvas. Element number 3 is now the right canvas. So I have 2 big canvases on there as the second and third elements of my grid. Now, I got a console, canvas, canvas. Now I'm going to add some interactors, because it's just that cool. I'm going to create a text field, which is a new JText field. Text field I declared as a private instance variable. I just showed you that. Maximum size is 10. I will add a label to it, and the label is just going to be called some text. So it'll write some text in the southern region. Then it will add my text field in the southern region. And then, as at this point you should come to know and love, you always got to remember to add your action listener. Very common thing that happens, people create a text field and they're typing in it and stuff in their program and nothing's happening and they're tearing their hair out and they're wondering why. They just forgot to add the action listener. Know it, learn it, live it, love it. It's a good time. Action listener for your text field. And then I'm going to add 2 buttons just for good times. So I have my text field. I'm going to have 2 more buttons, a button that says draw on the left and a button that says draw on the right. Okay? So let me show you what all these things are going to do before I show you the rest of the program. So I want to show you text and graphics. Okay? I have my console over here. I have 2, you can't see them, but they're side by side, 2 different canvas windows over here. Here's some text. I can type in hi. You typed hi. Wow. Yeah, it's that exciting. Draw left. In my left canvas, I'm just drawing rectangles. I'll show you how I do that in just a second. Draw right. Drawing in my right canvas. Ooh, how did I make that happen? All right, so let me show you the rest of the program. So I've set everything up, right? Console, 2 canvases, text field, and 2 buttons at the bottom. Here's where all the action's going on. When action performed is called, right? That means someone's interacting with one of the interactors. There's nothing else I can do in the program except interacting with one of the interactors. First, I check for the text field. If the interaction was the text field, so if the source of the interaction was the text field, I write out you typed and the text in the text field. This will go into the console, because anytime you do a println, the text always goes into the console, so it just shows up in the console. Not a whole lot of excitement going on there. Alternatively, if the thing they did was not to type into the text field, they clicked one of the buttons. So I say, hey, and I'm showing, I could have either done it all with get source or all with get action command. I'm using both just to show you that you can mix and match if you want. So I say, hey, what was the command, get action command? If it was draw left, then what I'm going to do is I'm going to create a new filled rectangle. Let me show you create new filled rectangle. It's very simple. It just creates a rectangle that's 50 by 20. And yes, they should have been constants, but I didn't make them constants, so I wouldn't have to scroll down and show you the constants. I set it to be filled, and I return the rectangle. So all it does is create a filled rectangle and say, hey, here you go. And all I do is I take that filled rectangle and I add it to my left canvas. So because it's not a graphics program, I can't just say add with a rectangle and add it. If I want to add the rectangle somewhere, I need to specify which canvas am I adding it to. I'm adding it to the left canvas. So I say, oh, left canvas, add to yourself this rectangle. Where are you going to add it? At X location 20 and at Y location left Y. Left Y starts out with the value 10. And every time I add something, I space down my Y. So I'm just making Y go down by some spacer amount, which is 30. So all it's doing is drawing a rectangle and essentially moving down. So I'll draw my next rectangle below it, moving down to draw the next rectangle below it. And I do exactly the same thing for the right-hand side, except after I create the filled rectangle, I have a separate right Y, which keeps track of how low I've gotten on that side in terms of the Y coordinate. And I add to the right canvas. That's the only difference. Okay? So when I run this program, right, some text, right, again, if I type in great, if I type in great and hit enter, it generates the event which does this println on the screen, right? It generates this event over here, this action performed. The source was text field, and I write out the text on the screen. If I click on one of the buttons, draw left, draws the filled rectangle, and it's incremented the Y on the left-hand side. So the next time I click draw left, it draws it lower and lower and lower. And draw right does the same thing. Notice that the X location for both this canvas and this canvas, when I add the rectangles, are both at 20. The reason why it shows up 2 different places in the screen is because there are 2 different canvases and there's kind of an invisible border here. Okay? So you can create text, graphics, and interactors all together and just go to town. Any questions? Alrighty, then I will see you on Wednesday.